Graph the linear inequality. Don't forget to carefully name and test a point. Y is less than or equal to negative 4x minus 3. Step 1. Replace the inequality sign with an equal sign. That will give us y equals negative 4x minus 3. Step 2. Graph this equation, the one with the equal sign. Now, if it's going to be a solid graph if there's an equal portion included in the original inequality, if it's less than or equal or greater than or equal. Otherwise, the graph will be a dotted graph. That's the case where you were given an inequality with just less than or greater than. So you have to make a decision which one you have. Okay, we're going to graph y equals negative 4x minus 3. Compare it to y equals mx plus b. We see the slope is equal to negative 4 over 1. And the y-intercept is 0b, so it's 0, negative 3. We're going to graph the ordered pair 0, negative 3 on the xy axis. Now, I want to apologize for all the scribbling that's there already. It shouldn't be there, but I can't get it off, and I shouldn't have mentioned the test point yet. So pretend the scribbling and the test point comment is not on there at this moment. Just write the x and the y axis and get ready to graph. We're going to graph the ordered pair 0, negative 3. We know that lives on this line. And then we're going to use the slope like a road map to find our second point. Now remember, slope m is equal to rise over run, which in this case is negative 4 over 1. So that implies that the rise is going to be rise 4 units. And I accidentally wrote up and I meant down, so I'll have to correct that and then, because of the negative sign. And then run 1 unit to the right since we've got a positive 1 on the bottom. So that's 4 units down, D-O-W-N, down, and then 1 unit to the right. So we graphed our 0, negative 3, and from there we're going to move 4 units down, 1 unit to the right, and graph our second point. And now we're going to connect the 2 points together with a straight line and extend it. Okay, notice we used a solid line and not a dotted line. We used a solid line because the question had an inequality less than or equal to, not less than. It wasn't missing the equal portion, it had it, so that meant we give it a solid line. Now pretend that scribbling's not there yet. We're going to use y less than or equal to negative 4 minus 3, the original question, to test a point that lives off of the graph. You have to choose any point that lives off of the graph. Now the easiest point to use is the ordered pair 0, 0 to test a point, but you can only use it if that point, which I just circled, lives off of the graph. Well, guess what? That point 0, 0 does live off of the graph. It lives off of that solid line that we drew. So we can use it as a test point in our inequality y less than or equal to negative 4x minus 3. Replace the y with 0, replace the x with 0, because we're using xy equals 0, 0. Simplify each side separately. This is the original inequality we're working with. We get 0 is less than or equal to negative 3. That is not true. 0 is not less than or equal to negative 3. So our test point failed. All right, what do? Well, since the 0, 0 that we tested failed to satisfy the original inequality, it means that all the points on the same side as a test point also will fail. And it means that all the points that live on the opposite side of that graph from where the test point lives will all pass the test. They will all be solutions to the inequality. So we're going to shade the opposite side of that line, opposite from where our test point 0, 0 lived. And that shading represents every ordered pair solution that satisfies the given inequality. Now, I was told to carefully name and test a point. So I named it by writing it really big right there in the box. The test point was 0, 0. And I showed all of my work, how I tested it by plugging it back, that x equals 0 and y equals 0, back into the original inequality and checking by simplifying each side separately and then see if the resulting statement was true. It was not true. It failed, so I shaded the opposite side.